In 4.2, number 48, they're giving us a function right here of y is equal to x plus sine of x, and they're asking us to find the maximum and minimum value of this function on a closed interval here from 0 to 2 pi. So let's get working on that. We should know by now, everybody, that extreme values can only occur at two possible places. That would be endpoints and critical points. Well, we already have two endpoints right here, so I'm definitely going to need to check the value of this function at 0 and at 2 pi, but we want to look for critical points as well. So the derivative of y with respect to x is going to equal, derivative of x is 1, and the derivative of sine of x is just going to be cosine of x. And we have critical points anywhere that derivative is equal to 0 or undefined. Now, that's never going to be undefined because it's the sum of two continuous functions, so therefore its domain is going to be all real numbers there. But I definitely think this thing could equal 0. So bringing the 1 to the other side, we would want to know where cosine of x is equal to negative 1, and that occurs at an infinite number of x values, but only once in the interval between 0 and 2 pi. Cosine is equal to negative 1 at pi radians. So that is the only critical value that we get from our derivative here. So what we now need to do in a case like this is evaluate the function at every possible candidate for an extreme value. So I'm going to combine notations right here, and we're going to evaluate y of 0, and then y at our one critical value, which was pi, and then y at our right endpoint, which is 2 pi. Three potential spots we have to evaluate. And let's see how much of this we can do without a calculator. Putting a 0 in there for all of those x's, that's going to be a 0 plus sine of 0, so we're going to get a big fat 0 for that y value there. Putting in a pi, we're going to get a pi plus, and the sine of pi is going to be 0, so we're going to get pi for that y value as well. And putting in a 2 pi now, we get a 2 pi going in for the x, plus sine of 2 pi is going to be 0 as well, so we're going to end up with 2 pi for that y value there also. So that's where we're at with this function right now. And again, I meant to look here. Sorry. I want to make sure I'm reading my directions correctly here. And let's see. I believe it just said to find absolute max and absolute min. Trying to double check that. Sorry. So number 48. I had it. I lost it. There it is. There it is. Yeah, find the maximum, minimum and maximum value of the function on the given interval. There you go. So our maximum value is going to be 2 pi right there. Notice they just said they wanted the maximum and minimum values. And our minimum value looks like it is going to be 0. And that's our min. And if we really wanted to see what this thing looked like right here, I'm going to just try to verify my answer right here. I'm going to graph that function on this interval here, guys. So let's see, add a page right here. We'll put a graph on there. And y was going to be equal to x plus the sine of x. Okay, and that's what that thing should look like. Kind of interesting. And I kind of want to narrow this thing down to just the interval here that we were interested in. So let me go to Windows Zoom and Windows Settings. And my x minimum on this interval, we wanted that to be 0. And then, let's see here, our x maximum was going to be 2 pi, and I think I can just type that in the way it looks. Now for my y values, I now have a guess as to what these min and max values should be. We thought the minimum value was going to be 0, so I'm going to go just a little bit beyond that and put in a negative 1, and then for the maximum y value there, we came up with a max value of 2 pi, which is about 6.28, so I'm going to put a 7 in there. And I'm going to hit OK and graph this thing, and it kind of looks here, guys, like, yeah, this is telling us what we thought. Our minimum value is happening all the way over here in the left. When x is 0, looks like y is 0. Our max value happens all the way over on the right when x is 2 pi. You can see that 6.28 down in the lower right-hand corner. That y value is a little under 7. I think that's 6.28 as well. The one interesting thing is that we did come up with, let's not forget, a critical point right here at x equals pi. But if you look at this y value that we came up with right there, we did not get a minimum or a maximum at that point there. And the graph kind of supports that idea, guys. Right in the center of this graph, we have what looks to me to be a point of inflection. Now, I can't say that for certain until I look at the second derivative and figure that out, but It looks like we have a spot where the function was increasing to the left of pi, then it levels out momentarily. It does look like there's a horizontal tangent there, but then it continues to increase after that. So remember, you can have a critical point that isn't an extreme value, and that's exactly what happened right here. At there, we got x equals pi, which was a critical point, but neither, not a max nor a min. So that can happen in a case like that as well. Okay, that's how we handle number 48 in section 4.2.